We saw earlier how sodium metal will go together to make a sodium ion, and chlorine atom will go together to make a chloride ion, and these two go together to make a charge-neutral molecule known as sodium chloride. And although those charges do exist, we don't show them because molecules are charge neutral. But how about magnesium and chlorine? Well, it's a little different for that. Magnesium actually goes to magnesium +2 ion. Chloride still goes to -1, and these are going to combine differently. As you can see here, they don't combine in a 1-to-1 fashion, as does sodium chloride. It combines in a 1-to-2 fashion. So what we want to do is to look at this process of making molecules from atoms in two phases. We need to know how to turn atoms into the ion. How do I know if it becomes a +1 or -1 or +2? And then the next thing we want to be able to do, which we'll discuss later, is how to then turn those ions into charge-neutral molecules. But first, the atoms to ion part. Now, the driving force in all of this is that noble gases, group 18, are notably stable. And atoms, too, they want to be stable. So the way atoms get to be stable, similar to the noble gases, is to achieve the same number of electrons as its nearest noble gas neighbor. Now, what that normally means is the atom's going to have to give up electrons, or it's going to take electrons. And of course, when they do that, they're going to become charged. And that's how different atoms get different charges. So let's look at a few examples. But before I do, I want to simplify the periodic chart so that I'm only looking at representative elements. Next, I want to label each of our groups. Group 1, 2, 3 through 12 are actually in this group that we deleted. 13, 14, 15, 16, 17, 18. Oops, did I forget the ones in front of each of those? I did. But wait a minute. For purposes of counting electrons, it's best that we don't. Now, let's take a look at why sodium became a +1. Here's sodium, and notice that it has 11 protons, and therefore it has 11 electrons. So for sodium to make its way to the noble gas column, it has two choices. It can march forward until it has 18 electrons. That is to say, it can gain 7 electrons, or its nearest neighbor is also neon, or it could lose 1 electron. And as we said, it wants to get near its nearest neighbor. So what sodium chooses to do is lose 1 electron. But you already knew that. Sodium will lose 1 electron, and so its charge becomes +1. Well, let's have a look at magnesium. Magnesium has 12 protons, therefore it has 12 electrons. So when it marches to the noble gas column, it can either gain 6 or lose 2. And its nearest neighbor is to lose 2, therefore magnesium will lose 2 electrons and therefore has a net charge of +2. And that's really all there is to it. Next, let's consider aluminum, which has 13 protons and therefore 13 electrons. Its nearest noble gas neighbors is either a noble gas with 18, which means it would have to gain 5 electrons, or 10, which means it would only need to lose 3. Therefore, it's going to lose 3 electrons. So when aluminum atom loses 3 electrons, it becomes aluminum cation. Moving now to chlorine. Chlorine has 17 protons and therefore 17 electrons. To get to the noble gas column, it either needs to gain 1 electron, up to 18, or lose 7. It chooses to gain 1 electron. And so chlorine will gain 1 electron and become chloride ion, a chlorine with a negative charge. Moving down to oxygen. To get to the nearest neighbor, it needs to gain 2 electrons. And so oxygen, when it becomes an ion, will carry a -2 charge. How about phosphorus? It can go to 18 or it can go to 10. Its shortest path is to go to 18 by gaining 3 electrons, and so phosphorus will become a -3. Similarly, you can figure out that calcium will need to lose 2 electrons. It will become calcium ion. And lastly, sulfur will gain 2 electrons and become sulfur -2 or sulfide ion. And so for the atom to ion step in making a molecule, it's a relatively easy task to figure out what the charge on the atom is going to become. All one needs to do is to march the element to the noble gas column, taking the shortest path, and counting how many electrons the atom needed to gain or lose to do that.